happy and I think extremely excited to finally publish our trust portal. It's a way to become more transparent as a company. Most of our code base is open source for years, but we want to build more and more trust. And at some point, we realized that just open sourced code is not enough to convince someone that we're actually secure, because code base became extremely difficult to analyze externally. And therefore, we're launching Reclaim Trust Portal, which is the way for everyone to see our security vulnerabilities from any perspective or from any understanding of the word security. Basically, we were doing external audits from time to time, which took a few months. Our code base was completely changed. And then, we got as an output some audit, but then code was already different. So it was not too honest to say, hey, we're audited and this is the code which was audited and we're actually secure. Therefore, we came up with an idea of continuous audits. Basically, the Reclaim Trust Portal, which is running security analysis on different perspectives on the Reclaim protocol and updating every day, week, month what vulnerabilities might appear in the code so we can proactively react. Well, I would like to ask Lyth then, from your perspective, who do you think it will be mostly useful for?
First, I want to say hi to everyone. To be honest, at the beginning, my perspective about trust, it was like we are targeting our clients to answer any question that we get about our privacy. But when I start working on it, it turns out that we need it for us to know our products more, to ensure from our privacy, from our security, because many things could be leaked mistakenly while we do any feature or something. So after a while, I figure out there are many things that we need to pay attention for it. And this transporter helped us too much to figure out that about some data privacy, about some coding bugs. So yeah, at the beginning, yeah, as I told, I thought it's for our clients. Then no, we need it for us.
I definitely agree with you, and this was somewhat a weird realization for me as well, that we want to be transparent for our customers, for our prospective customers, for end users who might not even know, to be honest, that they're using Reclaim under the hood in some product, but yet if they want to dig enough, they want to be sure that their data is not leaked, that there is no vulnerability on the way. And then I just understood that this is not for that. Of course, this is for them as well, but this is for us to be able to present to everyone that we are secure, we're safe, it is safe to use us. Being able to present comes from the understanding that at every moment, every day, every week, we analyze proactively what can cause security vulnerabilities and we address those, rather than waiting for an external audit, which can happen once a year or maybe even more rarely. We might run external audits to be sure from time to time because, we're using AI in our trust portal, and AI might hallucinate. It does hallucinate. Of course, it improves every day and every week, but still human verification of what we find or of what we don't find is necessary from time to time. However, between the times when we run one audit or another audit, we can be more sure, if I may.
What, who do you think the portal is for? Integrator, end user, or internal team? How do you see it?
Amazing question. Actually, for everyone. But as you mentioned, let's think about these three groups of people. Basically, integrators are tech teams that approach us and they want to embed Reclaim in their product. And then there becomes this back and forth conversation, which usually repeats itself, to be honest, with different integrators, in which they ask about what are our trust assumptions, what if there are bugs. They maybe look at our code base and they try to analyze it itself, or they might trust us on something. And we basically want to reduce, first of all, our efforts, repeating all the same answers, but second of all, want to reduce the trust assumptions, mainly by saying, okay, you don't need to actually trust us. You just open our trust portal, in which We're running audits all the time. Here are our findings. Here is how we address them, and there is no need to blindly trust us. You can verify on our own that we proactively monitor our security. On the other hand, as you mentioned, there are end users of Reclaim Protocol. They might not even know, to be honest, that there is the Reclaim Protocol happening under the hood, but actually, if they want to understand how their data is used and transferred and fetched, if they want to dig into it, they will find our trust portal and they will see that we are actually credible. And finally, it's just us. We, as I mentioned, we proactively will catch any regressions, meaning that at every moment we will be sure or almost sure that there are no security vulnerabilities in our code base. And as it gets more and more complicated, it is more and more difficult for us to control it on our own, while running continuous checks by AI allow us to prevent causing new bugs.
So other question for now is like, can you tell us when did you decide that we need this? And
that's a great question, and I'll be precisely honest here. A few months back, we were considering running a security audit externally, and then the process was as usual. We contacted a company that specializes in audits, and that's when something sparked that we can actually, well, just run AI checks if we calibrate it well enough, if we run it often enough. And well, maybe not as secure as if we were running external audit every week, but no one actually does it. So we will be as secure as we can be with such a setting. Due to new customers coming to us, they got bigger, there are more, every proof costs more, and if a proof is forged, then we lose credibility, our customers lose money. We need to act proactively and we need to be sure in real time that we are secure. Well, I believe it's finally time to make a transition to specifics. As I've mentioned, we consider different sorts of security, and let's discuss what we mean and how we define these sorts of security. Elias, could you please start with telling us about the data privacy section at our trust portal?
yeah, so before I start talking about data privacy section, I wanna just go very briefly about what is actually Reclaim do. So technically we have two paths of our claim work. We do have portal and we do have in-app SDKs. So technically the user login into the website, we extract the data that we need to verify it without revealing any other sensitive data or without revealing any other data. So just like what you are looking for, we extract it, and then we generate something called ZK proof, which is zero knowledge proof, that verify that this data belongs to you and without revealing any other data. And for that to work, we need TLS handshake to be done with the correct server. So like all this computation, it's happened on client side. Whether if using in-app SDK, everything happen locally on mobile, or if using our portal, so we run our portal on a remote browser, which is run inside TEE. So we ensure like even us, like we can reach this data or any information. So any PII or sensitive data, passwords, page info never go to our backend. So technically our data privacy section here, we are claiming that any PII data for the user never reach our backend. So technically what we doing here is we are fetching 10 random samples of sessions that happen using Reclaim. Then we pass all the logs that came to our backend into AI to analyze this log to show that if we do have any PII or any sensitive data related to the user password, username, anything. Then like the AI showed us that we don't have any. So yeah, this is our data privacy section.
Well, so you mentioned that we prove it. Could you please elaborate on how exactly we prove that there is no PII happening? There is
Yeah,
data
yeah,
that we see.
yeah. So technically, we do have some claims that one of them is like we don't have any BI, so technically we do fetch 10 random sessions from our backend. We get all the logs of this session and we do pass it into AI. This AI like go through all the logs that we have, analyze it to ensure that it doesn't leak any user data, any password, any sensitive information. We do show this check. Uh, because like sometimes unexpected data structure can be sneak into the logs or whatever. So it's ensured that nothing sneak out, nothing logged by mistake. So technically we do have frontier model that analyze our logs and anything that comes out into our backend or database, technically it's showed in the logs. So right now what we're doing, we get all the logs that coming into our backend, we analyze it, and as it's showing here, as you see guys in the page, this model it works to analyze all the logs that we have to ensure that we don't have any PII or any sensitive data or any data related into personal information into the user. As we see here, like we do have clean result because like a few months ago we did a code analysis into our code, but the problem is like the audit doesn't know what actually the page is look like at runtime because sometimes unexpected data could be sneak out. Audit code was not enough to ensure that we don't leaking any PII.
Thanks for the answer, Laith, and let me proceed to the next, somewhat a section of Trust Portal, but more of a discussion about why Reclaim protocol is secure and how we ensure that it's secure and it does what we want it to do, namely that there is no way to tamper any proofs and all the verifications are actually coming through all the checks that we want to happen inside the Reclaim protocol. And let me continue with asking you what is the real problem that the tamper-proof verification section solves in our Trust Portal?
So yeah, so technically many of our customers came to us because they do have problem with document verification, especially now in the AI era. Like faking document is pretty easy. Like you just like need to upload it to Gemini or any other model, and you can fake documents. So what we claiming in Reclaim that we can verify anything on the internet. So technically, we want to provide geometric opposite guarantees that if one byte change in the user data, the verification is going to be false. It's going to fail. So if we guarantee that if you receive a reclaim proof, like you can be confident that the data is true.
Absolutely. To elaborate on what you just mentioned, this is something we call provider hash, where provider means rules of how to prove something from a specific website. Let's say your age from your government portal or the amount of money you have from your bank account. This combines a lot of rules that we enforce, and once any of these rules change, it automatically changes the provider itself and hence the provider hash. And as you mentioned, this makes the proof unacceptable by Reclaim. However, there is another side of it, which is cryptographic side, which is how do we actually enforce all those rules? How are we sure that the data that was fetched was from the website was real? How are we sure that a malicious user did not just create a TLS transcript that looks plausible but actually didn't come from a communication with a real target website? And here we resort to help of two helper parties, which we call testers, and both of them are running inside TEs. Basically, one of the testers hold the TLS key while the user themselves doesn't know the TLS key. This basically solves the problem of proof tampering in the sense that the user now cannot compute a plausibly looking transcript of the TLS session. Why I mentioned two TEs? Well, basically, we also don't want to rely on TEs too much. There is a long line of works creating attacks and showing attacks on TEs confidentiality property, and we want to be sure that we don't rely on them on a single TE too much. Thus, we distribute the knowledge and we distribute the trust between two TEs in the way that rather TE being broken, does not allow the attacker to, first of all, create a malicious proof, and second of all, to steal any of users' data. This is, and as I mentioned, we're running this in TEs, which also have another property, which is integrity. In simple words, we at any time we can verify that the code which is running inside TE, inside any TE, is the exact code that we asked it to run. And everyone else can compare it against the code which is in our GitHub.
Actually, yeah, anyone can easily like clone our repos because we are open source code. We can ask Claude whether what we are saying or what we claim is correct or not. Also, like we have been audited by many companies like Zelek and ZK Security, but those are from 2023 and likely now they are outdated. Like it's been already 3 years. And now, and in the meantime, we are talking to fresher like rounds to do like more and more audits. But in the meantime, we use this time to audit ourselves by continuous AI check that it's run also weekly. So yep, that's also like briefly of how our tamper proof verification is working now in the trust portal.
Great, thank you. And now switching from theory to practice. What happens if someone actually tries to run man in the middle style attack on Reclaim protocol?
Yeah, so technically now what happened at the end after the proof is created, like the proof is sent back to the client backend. So technically he can run something called verify proof, which is like verify the signature and the proof hash with what we have in our backend. And any tampering or man in the middle attack in the middle, it's gonna throw an error. So we do have also real story that happened recently. An airline in status match program saw 100 of fake proof that had been submitted, and zero passed because of verify proof. Like hacker always try cryptographic artifacts, but it don't bend.
Clearly, everyday hackers are targeting us or might be targeting us. This is something we learned, and this is probably another reason why we want to proactively audit our security. We want to catch them on our own every day, every week, every month before it actually becomes problematic. Well, back to theory again. We actually were and are actively theoretically verified and analyzed in the paper, in the recent paper, proxying is enough, basically saying that the proxy-based approach is secure in general. On the other hand, this is the architecture which is gradually sunsetting, and we're transitioning more and more proofs onto our new architecture, which I already mentioned, the 2TE architecture. And there are a few works in progress into this direction. The main one is formal end-to-end security proof of our new architecture coming up in the next few months. We'll be happy to share once it's actually out. Great, so now that we discussed briefly our new architecture from theory and practice, we mentioned TEs a few times. Could you please elaborate on what kind of guarantees in practice TE gives us and what we can actually show in our trust portal to actually become more transparent on the use of TEs?
So yeah, technically we do have this section which called TE checks. So here we do have a daily cron that every day that it run, it fetch 5 random sessions and it get the image hash that running inside this session to ensure that it's matching our open source code base. So technically TE is like trusted execution environment given to hardware level guarantees, which is like what code is running inside. And the second guarantee is like even us cannot like has no backdoor access to this TE. So technically what we're doing here is taking this session, matching what we are publicly showing, like as you can see here, you can see view on GitHub, which like showed you our public image hash, and we match what we have in the session as we match it with what we publicly showing. Even for remote browser here, showing that the browser runtime image hash plus the verifier browser runtime a tester image hash.
Amazing. Thank you so much. And I believe we can proceed to the next section, which is called supply chain. Would you please elaborate on what is the problem with supply chains and why do we need even such section on our trust portal?
So yeah, technically here is just what we're doing is we giving our clients more transparency that for sure, like we are using a lot of libraries, same as like same as everyone. So companies can get compromised or any bugs could appear in any library. So we want to be transparent about dependencies as well. So technically here, like GitHub gave us like dependent bot alert. We do, but so far those aren't public. Like just to give more transparency, we like gather them all in one page for our clients. Also, like we do show here the fixes, not only the reports.
Great. And just to elaborate on that, we deliberately have a lag between the moment we realize or we notice that there is a problem in the supply chain and we fix it, and then only after we are sure that the fix was implemented we post it online in order to avoid just showing potential attackers how to attack us or using which direction to attack us from.
Okay, so now we're gonna move to a quite important part. So could you tell us what is white paper?
Of course. Basically, white paper is a semi-formal document that describes how we work under the hood, and usually this is something more mathy, cryptographical. In our white paper, we have claims such as user never learns the key, which is somewhat unclear how to verify. Should you go through all the code, all the functions of communication? What if in some sections something deviates from something you observe? And well, this is something we want to enforce by the trust portal. We want AI to analyze it from all perspectives and to say that whatever statements, whatever claims we have in our white paper, they correspond to the reality. And this is something that is actually happening in our code. White paper gives a gist about what is happening under the hood and allows people with mathematical background or cryptographic background to understand and to verify that the technology, at least in theory, in paper, is legit. So, Laith, would you tell us about how we actually address such a vague problem, maybe even philosophical, that how do you pin our real code to the white paper? How can you be sure that whatever prose text is written in the white paper actually corresponds to the code we're running?
Okay, so as Kirill mentioned that we do have some claims in the white paper, technically we do have around 24 claims. So technically what we're doing is we mention the repos that related to the claim. We take these repos, we spread it into chunks, and we pass it to AI along with the claim and the hint. So AI verify where each claim are written in publicly in our code. So technically, the AI return for us the reason why this claim is either verified or partially correct or it's incorrect claim. And also alongside it mention where exactly in the code like this claim has been written, like as we see here in the claim, like for example, this one, like all sensitive data masked by the user is correctly reapplied when TA reconstruct the full request ciphertext, ensuring no sensitive bytes are exposed to either TA. So technically, this one of our claims that mentioned in section 3.23 algorithm 3 step 9 page 14. And here we pass it to AI, and this AI response why our claim is verified and is correct. And here it showed where in our code like this claim has been written or implemented, let's say. So yeah, and we do run this one per month to ensure that we are continuously checking our white paper that what we claim inside our paper is really implemented in our code.
Thanks, Laith. And well, I think some of you may ask, okay, you probably made AI just approve whatever you wanted. What is the how can others be sure that hint doesn't say please approve this and write something plausible? As we mentioned, we're building transparency on this, and to achieve higher transparency, we want to be transparent with our trust portal as well. Basically, hints are public and anyone can see them, anyone can see the claim, everyone can see our open source code. If they don't trust us, they can rerun it on their own and get the same output. On top of that, when AI approves or disapproves our claim about white paper, it writes reasoning about it. So basically, when the claim is approved, it usually says something like, go check this function, it does this and this, which proves that the claim is correct. This means that someone who doesn't trust our AI can also do it on their own, go to our code, and instead of browsing through our whole code base or browsing through a huge repository, they already know, hinted by AI, where to look for something they don't believe in and how to ensure that AI is not hallucinating. And we did not ask AI to just approve whatever we wanted. Finally, I would like to ask Lyeth about how we deal with issues that we find. These are issues including PII findings, these are issues including security findings or poor white paper adherence.
Yep. So going through the process right now, as we all know, AI could hallucinate, and we can't guarantee 100% that what AI provides is 100% correct. So technically, we do evaluate manually also what AI showed us. So sometimes AI could consider something as very critical or very dangerous or something it's incorrect in the flow, but it turns out that it's just only part of our flow. So right now what we're doing, so firstly we re-evaluate what AI findings is about our security. Then we do assign the task for the dedicated engineer who's responsible on this task. So currently it's me. Yeah.
It seems like you mentioned abilities to actually manually check and change whatever we present on our trust portal. And I believe this is yet another important level of discussion, saying that obviously we want to manually see what AI finds. We want to manually analyze because AI is not well understood. AI is just a black box for us, and whatever it finds, we want to consider with all the level of importance. But at the same time, AI hallucinates a lot in many direction, and we don't want false positives to just show on the trust portal. The fact that we show it is just acknowledging and growing transparency on what kind of problems we solve, what kind of problems we analyze and observe. Like, would you share something that Trustportal already allowed us to find, and maybe something that was surprising for you or unexpected?
To be honest, there is something that was really surprising for me that after 1 month working on being sure that our code is not leaking any PII, after first run in the after first run of our trust portal, we found out that it was 6 or 5 out of the 10 session that it has PII. So that was shocking for me because like I ran the audit few times on our code base and it was showing that it was free PII. I saying there is no PII logging. That's actually the point where I find out that the trust is for us. It's not only for our clients or for our users. So it helped me to figure out because as I mentioned, AI understand the code base, but it doesn't understand what's going on at runtime. So we found out that there are few paths actually. We could also log there some PII, uh, which I was not aware of, and we like directly ran out to fix that, and we now are, let's say, almost 100% sure that we don't have any PII leaking. So this was one of the proudest things that I could catch using Trust Portal.
From my side, it was interesting that when we finally set up our white paper adherence page, it turned out that white paper is not completely claiming what is happening in our code. And well, to be transparent, the bug was not something large. It was more about at which step we share the certificate of the website with the client. And as it was written in the white paper, in the end of handshake session, TE that actually establishes the TLS connection with the website shares it with the user. This is exactly the claim that I copied to the from the white paper, and I had no doubts that this is exactly what's happening. But then the AI told me, no, the claim is false, and I was surprised, honestly. And it's not about security at this point. It is about, and in reality, the certificate was not shown to the user, but rather it was just added to the proof bundle so that the final attester, the final verifier, can check that the connection was with a legit website. And as I mentioned, this is not about security, but rather about probably communication gap between me and the engineering team. This became an interesting direction that Trust Portal pointed at. Instead of finding a bug in the code, it found a bug in the white paper. And this was something I definitely didn't expect. Well, I believe there are many more interesting findings that we're going to notice after extensive use of Trust Portal.
Okay. So to wrap up what we are talking about, please, I encourage you guys to check out our Trust portal, which is trust.reclaimprotocol.org, and we are happy to answer any questions or any inquiries like you have, guys. Please DM us on Twitter, Reclaim Protocol, or send us an email to admin@reclaimprotocol.org, and we will keep iterating and announce our new products or features. Thank you, guys. Thank you, Kirat.
Thanks, everyone.